Theoretical recap. In the world of DevSecOps, one of the most common and dangerous mistakes a developer can make is accidentally committing a secret, a password, an API key, a database connection string, a private token, directly into a Git repository. Once a secret is committed, it becomes part of the repository's history, even if you delete it in a subsequent commit. This is a critical point. Deleting a file or a line in Git does not erase the past. Anyone with access to the repository, and sometimes even without, if the repo is public, can run git log, git show, or git diff to retrieve the exposed data. A common mental model. Think of Git history as a ledger. Every entry is permanent unless you explicitly rewrite history using commands like git rebase I, git filter branch, or the modern git filter repo tool. Simply adding a new commit to fix the secret leaves the original commit fully intact and readable. Common mistakes include believing that a .gitignore added after the fact will retroactively protect already tracked files, thinking that making a repository private after a leak is sufficient. The secret may already have been scraped by bots, and forgetting that C/CD pipelines, forks, or clones may already hold copies of the exposed history. Mini example. A developer commits a file config.py containing API_key equals skprod ab123 size. Even after removing the key and committing again, running git log p will reveal the original value in the diff of the first commit. The correct remediation requires rewriting history and immediately revoking and rotating the compromised credential. Workshop brief. This workshop puts you directly in the shoes of a developer who has made a classic and dangerous mistake, committing a secret into a Git repository. Your mission is to reproduce this scenario in a controlled environment, observe the consequences using Git's inspection tools, and then apply the correct remediation procedures. This exercise is deliberately hands-on and requires you to think critically at each step, not just execute commands mechanically. You will work inside the lab virtual machine you set up in the previous workshop. All operations must stay within your local environment. Do not push anything to a real remote repository, and never use actual credentials from any real service. Create fictional secrets for this exercise. Step 1. Set up a test repository and simulate the leak. Begin by creating a fresh local Git repository in your VM. Initialize it. Create a few innocuous files to simulate a realistic project structure, for example, a readme.md, a requirements.txt, and a simple Python or config file. Then deliberately introduce a secret into one of your files. This could be a fake API key, a hard-coded password, or a database connection string. Commit this file normally, as a distracted developer would. Make at least one or two additional commits after the one containing the secret, to simulate the passage of time and further development. Observe how the repository history now looks. Step 2. Investigate and confirm the exposure. Using Git's native inspection tools, git log p, git show, git diff, locate and extract the committed secret from the history. Document exactly which commit introduced the secret, what the full commit hash is, and what the exposed value looks like. This step is important. It trains you to think like both an attacker discovering a leaked credential and a security engineer performing an audit. Take note of your findings. You will need them for your submission. As an additional exercise, use a dedicated secret scanning tool. You may use Trufflehog, Git Secrets, or Git Leaks, all available as open-source tools. Run a scan against your repository and verify that the tool correctly identifies the leaked secret. If you encounter difficulties installing these tools, consult the official documentation and feel free to try more than one option. Step 3. Attempt the naive fix and understand why it fails. Now simulate the naive approach. Create a new commit that removes or replaces the secret with a placeholder. For example, API_key equals redacted. After this commit, use git log p again to confirm that the original secret is still fully visible in the history. Take a screenshot or copy the relevant output. This step exists to make the danger tangible and visceral. You must see with your own eyes that a simple deletion commit does not protect you. Step 4. Apply the correct remediation. Now apply the proper fix. You have two main options to rewrite Git history and permanently remove the secret, using Git filter repo, recommended, modern approach, or Git rebase I combined with manual editing for simpler cases. Choose the approach that fits your situation, research how to use it, and execute the remediation. After rewriting history, verify by running git log p again and rerunning your secret scanner. The secret must no longer appear anywhere in the repository history. Document the commands you used, the before/after state of the log, and any difficulties you encountered. Remember, in a real-world scenario, rewriting history on a shared repository requires coordination with all collaborators, force push warnings, recloning, etc., and the immediate revocation and rotation of the compromised credential. Note this in your submission even though it does not apply to your local test environment. Step 5. Prevention. Set up a pre-commit guard. Finally, explore how to prevent this class of mistake from happening in the first place. Research and configure a pre-commit hook, using the pre-commit framework or a manual Git hook in .git/hooks/precommit that detects secrets before they enter the repository. Test your hook by attempting to commit a new fake secret and verifying that the hook blocks the commit with an appropriate warning message. Document how you set it up and what the output looks like when it catches a secret. Submission and reflection. You have 3 days to complete this workshop and submit your solution before the deadline expires. Your submission must include a written summary of each step, what you did, what you observed, what commands you used, screenshots or terminal output excerpts for key moments, the initial leak visible in history, the failed naive fix, the successful history rewrite, the pre-commit hook in action, and a short personal reflection, 5 to 10 sentences, on what this exercise revealed to you about Git security hygiene and how you would integrate these practices into a real team workflow. You are fully authorized to consult all previous course materials, official documentation, and any internet resources you find useful. You may work alone or seek help from peers, forums, or AI assistants, but the written reflection and the documented commands must be your own work and reflect your own understanding.